Hello folks, this is Tom from anti-proton.com, and I have just finished a 3-hour count. I tested this rainwater sample here that I took yesterday. If you look closely, there are floaties in it. This concerns me because, most of them are organic matter, I'm pretty sure. But if you look closely at the bottom here, there's a little bit of sediment. And most of that's probably hornblende, although of course hornblende itself isn't really actually technically a single mineral. It can be a multitude of minerals put together. I see some quartz in there too. None of that's usually particularly radioactive in any way, but I have to wonder if it's in any way, shape, or form throwing off my tests. So today during the thunderstorm, I'm going to collect new water samples that are completely clean and test them. And if I have to, I'll even filter them, because I'm worried that could be throwing off my results, and I just want to make sure that I have exactly correct results. Anyway, I ran the Geiger counter in the room, and I did it by itself for 180 minutes, which is 3 hours. I got 263 counts. Sorry, 200. It's morning time. 2,633 counts in 180 minutes. Do the math. You divide this into this. You get 14.277 counts per minute on average. I did the same thing again, but this time I used the water baggy. There's the water baggy, see? There's the water, you can kind of see it in there floating around. And I got, this time, 2,777 counts in 180 minutes. Remember? 2,633, 2,777. It's not infinitely more. You divide this into this, you get 15.4277 counts per minute as opposed to 14.6277. So that's nearly a count per minute more. This is actually pretty close to, pardon me for a good morning yawn. This is actually pretty close to the original test that I did for 1 hour. And as you can see, 3 hours made it probably just a little bit more statistically accurate, but also 3 hours still had the exact basic same result. Not very far off. What that tells you is that the water is slightly more radioactive, but not by much. Now here's the question. Why is it radioactive? And that's why I need to take an additional sample in today's rainstorm. And that won't do much for me for this one right here, of course. But today's rainstorm samples will be larger and cleaner. And because they're larger, I can test more of it and get a more substantial result. Now, what I might also consider doing, just for giggles, I might consider taking water and seeding it with potassium salt. Just to see, because then I will actually have radioactive water, just to see what it looks like, see what kind of effect it has. I'm curious how much potassium it requires for me to be able to detect it in a 1 or 2 hour test. In other words, I'm kind of seeing how sensitive I am. Keeping in mind that potassium salt is not always the best idea for these sorts of tests, and it doesn't necessarily mimic cesium or strontium very well. But regardless, I can safely say that this water is a tiny bit more radioactive than not having this water. It's a very small amount. But we shall see. I still don't understand how people are getting those, multiple millirem per hour. Keep in mind that 15.4277 on my Geiger counter, which is calibrated for cesium-137, mind you, but if the water had cesium-137 in it and that was actually the source, then this would equal 0.015 millirems. So, I mean, that's pretty small. I don't know how on earth they're getting that's hundreds of times less than what I keep finding on YouTube. I don't know where people are getting these numbers, but oh yeah. As you can see, there it goes. It's not very much. It ticked a little bit, probably more because of the static on the bag than anything else. Now, just to show you, my pen is not very radioactive. Also, oops, let me stand back a little bit here. I don't really have anything particularly radioactive in the room. Although keep in mind it wouldn't matter because I haven't actually changed anything in the room. So if I had to borrow uranium right here, it wouldn't matter. It would be the same effect over time. The number here would be just as high as this, and there would be a tiny difference, which would be equal to this. Alright, and underneath the board, you notice there's nothing there. No tricks. What is this little thing here? Oh, it's a furry. Yeah, furry. Yay, furry. Okay. Put that away from the furry. Mostly reading background right now. Anyway, so it does take a bit, doesn't it? But statistically it calms down over time. So that, folks, is the result of my initial test. We will get some more water and we will test later, and I'll see if I can run it for 3 or 4 hours at least to get a good average. Running little 10-minute counts is fine, but if you want to get really fine-tuned, like if you're trying to do surface contamination of food and that sort of thing, you gotta run it for many hours. Also, I now have a video camera that allows me to pause video. I think it will work. We will find out. If it does work correctly, then that would be great, because I would love to be able to pause and show you the starts and finishes of things. Anyway, this is Tom from anti-proton.com. I gotta go to work. Bye-bye.